Alright guys, welcome back. I'm excited to have you for another video. Today we are doing section 3.1, functions. So we're going to start with a nice little warm-up, kind of review what we did our test over. So let's solve these. We're going to subtract 5, same sign, so we add. 6 plus 5 is 11. But it wants us to graph, so let's go ahead and graph. We know it's going to be negative 11, open circle. And this says x is bigger, so we want to point to the numbers that are bigger. So, give you a couple minutes, take 5-10 minutes, go ahead and solve these, pause the video, come back once you've had them solved so we can check them. Okay, so you pause the video, you solved these, let's look at it. Alright, over here, going to subtract 0, gives me 7 is less than or equal to m. 7, close circle because the line underneath, and it says 7 is smaller than m, so m is bigger. Here, add 5, r is greater than 9. Go ahead and put a 9. Open circle because there's no line underneath, r is bigger. Minus 10, so negative w smaller than negative 4. Divide by negative 1 because there's a 1 here. When we divide by a negative, we flip. Negative divided by a negative is positive. To graph this, put a 4. Open circle, w is bigger. Minus 3, h is less than or equal to 6. Closed circle, h is less than, so smaller. Combine your like terms, that's negative 8. Add 8, j is greater than 17. We've got 17. Open circle, j is bigger. Combine your like terms. That gives us 5p. Minus 8, 1 is less than or equal to 5p. Divide by 5, we get 1/5 is less than or equal to p. That's okay. Fractions are totally cool here. So we've got 1/5. Close circle, and it says p is bigger. Last one. Add 9, n is less than 19. That is an open circle at 19, and it says n is less than. So hopefully you did pretty well, because, well, we just took a test over this. So, important thing, your notes are now going to be graded every Friday. If you are not getting the notes done in class, it is now homework. So please make sure you're taking advantage of the time right now and getting these notes filled out. So let's get to the new stuff. I'm excited. So in your notes, you have something along the lines of a function is where each x has one y. That's the definition of a function. So if it's not a function, we call it a relation. So not a function, that makes it a relation. Now I think for a, when they're ordered pairs, sometimes it's a good idea to make an xy. So let's give it a try, and let's see. So my first x is negative 2, and it goes to 2. My next is negative 1, and it goes to 2. 0, and it goes to 2. 1, and that goes to 0. And 2, and that goes to 0. So we check. This x has 1y, this x has 1y, this x has 1y, this x has 1y, and this x has 1y. So does each x have 1y? You betcha. So we've got a function there. Now let's look at b. Just find some room somewhere. So I've got 4, and that goes to 0. 8 goes to 7. 6 goes to 4. 4 goes to 3. And 5 goes to 2. But there's a thing where we have to get rid of repeats. So I have to get rid of this 4 here. And I have to write it here because I've already got a 4. And this 4 goes to 3. So that's a problem. Because if I look, this x has two y's. So that makes this a relation. Now if you look at C, do we have any problems? Do you see any x's that go to more than one y? I've got 1s and they go to 4 and 7. Well, that's a problem. So that's enough to say that this is a relation. Now you might also notice that we have a 2 and a 2 and they go to 3 and 8. That's a problem. 0 and 0 that goes to 5 and 6. That's also a problem. But we only need one of them to do that for it to be a relation. And the last one, this is called a mapping. And this is basically saying this x goes to 1y, this x goes to 1y, and this x goes to 1y. That's fine. This is a function because each x has one y. Now, these next couple, I want you to try them on their own. And I'm serious. You should pause the video, check to see if you understand what we just did. So go ahead and pause the video. When you got answers, let's check. All right, so I'm looking at this first one. Well, I see a problem here. I've got the 5s. They repeat. One goes to 0, one goes to 10. That makes this a relation. Over here, I've got -4. That's fine. -1, fine. 2, fine. 5, fine. No repeats in the x, so we're good. We've got a function here. This one's pretty easy. 2 goes to 1, 4 goes to 1, 6 goes to 1. So that's a pretty straightforward function. And the last one, this mapping. Well, 1/2 goes to 1, 2, 3 y's. That's a problem because each of our x's goes to more than one y. So that's a relation. So how'd you do? If you got 3 out of them, 3 out of 4 or 4 out of 4, really good job. If you didn't, take some time, rewatch my explanation. All right, moving on. Now we're looking at graphs, pictures. And I need to use what's called the vertical line test. And basically, I'm just saying, is there anywhere on the picture I could draw a vertical line that goes through more than one point? Well, right here, I drew a vertical line and it went through 2 points. It's a problem. That makes this a relation. Now, if we look at this next one, do you see any place where we could draw a vertical line that goes through more than one point? Yeah, I don't see them either. So that's fine. That makes this a function. There is nowhere on this picture where I could draw a vertical line and make it hit the graph twice. So, now I want you to try it. Again, pause the video, try it. See if you know what you've just learned and how to use it. Okay, so let's look at this. Do you see any place where I could draw a vertical line? I don't either, so we've got a function. Here? No. No place here either, so that's a function. On the circle? Oh yeah, lots of places. But we only need it to happen once. So let's just pick a random spot. That works. Once, twice. Sorry, circle. You're a relation. And the last one. Any spot? Nope. So this is a function. Again, if you got 3 or 4 out of those right, you're right where you need to be. If you didn't, please rewatch it and make sure you know what you're doing. Now the last part, the part that students really struggle with, domain and range. Now the domain is just all of your x's, all of your inputs. I have students remember this because D comes before R and X comes before Y. So let's see. I just need to plot each of these points. And a couple things we need to remember. We can't have any repeats. And we need to always put it in order from smallest to biggest. Alright, so here we go. This point right here, its x is -3. This one right here has an x of -1. This one has an x of +1. And this one has an x of 3. Now these are points, so we just do what's called a brace. It just says each of these points is an answer. Now, the range is our y. So let's look at those same points. This one has a y of -2. This one has a y of 0. This one has a y of, let's see, 2. And this one has a y of 4. Okay, these are points, so we draw our brace. And we check. Any repeats? No. Is it from smallest to biggest? Yes. So we are done. Now, points aren't bad. Now, when it's a line, this is where it gets just a little bit trickier. But remember, domain is just your x's. Now, I noticed that this, if we zoom in, x is here at -2, but also here at like 1.9, 1.8, 1.7. I don't want to have to write every single one of those. So I wish there was like an interval notation I could write. Wait, we learned about interval notation last chapter. So let's see, what's the smallest we go on the x right here at -2, and the highest at 3. Closed circle means bracket. Closed circle means bracket. Now there's another way to also write this as an inequality. So the inequality is smallest, biggest, domain is x's. We want the inequalities to always go this way. Closed means line underneath. Closed means line underneath. And there's your domain for that. Now notice, since this is a graph, a line, I have to either use an interval notation or an inequality. Now let's look at the range. Again, range is your y's. And we want to order it from smallest to biggest. So what's the smallest we go on y? Looks like, oh, right here. At y is -1. What's the biggest we go? Looks like about right there at 2. Closed circles mean bracket, bracket. But again, that's the interval notation. We could also write it as an inequality. Inequalities are smallest and biggest. But since the range was y's, I need to put a y in the middle because I'm talking about my y values here. Inequality has it facing this way. Closed circle means line underneath. Closed circle means line underneath. And there we go. There's the domain, the range. Now notice on the graphs, you have 2 ways you can present the answer. But when it's dots, there's only the one way, the brace. All right. You try these 2. Again, I'm going to ask you to pause the video, see what you learned, and give it a try. Don't worry if you can't do domain and range right away. It is a difficult thing, but it is something we will keep practicing now until the test. So give it a try. All right, we're back. Domain is the x's. And I noticed that these are dots, so I know that I'm going to have a brace. Now we want to make sure it's in order from smallest to biggest. So I look, the smallest I go on the x is, here, at -2. Then the next one is -1. Here is 0. That one's 0. This one's at 1. And this one's at 2. Since it's dots, we put a brace. Now range, again, remember, smallest to biggest, no repeats. So I look, what's the smallest I go on y? Oh, right here at 0. Now I notice the next one's at y is 2. Now there are 2 points, but we only have to write it once. So I'm just going to write a single 2. I know that there's 2 points, but remember, we don't write repeats. And again, same thing happens at 4. I've got 2 points there at 4, but I don't do any repeats. So I just write it as a single 4. And since these are dots, we go ahead and we write the braces. Okay, the last one. Domain, which is the x's. So let's see. Domain is always the smallest x to the biggest x. So smallest looks like it's at 1. Biggest is at 5. Closed circle means bracket. Closed circle means bracket. But again, we can also write it as an equality. Smallest, x, and 5. And it's an x because domain are x's. Make them face this way. Closed circle, line underneath. And the last thing, range, is your y's. So what's the lowest we go on y? Let's see. Right here. Right here at 0. There's no dot. No dot means closed. And what's the highest we go? Right here at 4. So the highest we go is 4. But again, we can write this as an inequality. Smallest, inequality like that. Now since it's a range, y's, inequality like that, to 4. Closed circle means line underneath. No dot means it's closed. And there we go. Now, a couple important things to remember. Reminder, I'm going to start taking grades over the notes. We have got to get better at taking notes. Also, the homeworks. We've got to do a better job of turning in our homeworks. So, we will talk about that when I get back. Please make sure you have gotten all the notes. And please make sure you're doing your homework. For some of you guys, this chapter is a chance to reset your grade. Please take advantage of it. Other than that, if you're still struggling with the domain and range, that is okay. We will practice it and practice it. You will be good by test day. I promise. Other than that, have a good one. Do your homework. And I'll see you guys when I get back.